Now I will discuss salient features of BC spooler. BC spooler employed a large half crossing drum. This is one side of the machine, and these are all spindles on one side. You have the other spindles on the other side, as this is a double-sided machine. So drums of all these spindles are mounted on a common shaft. This common shaft is driven by a common motor. So important thing to note here is that all drums are driven by a common motor, and this motor runs continuously. So whenever yarn breaks or package exhausts, the winding package is taken out of contact with the drum. If you observe here, all these spindles are in running condition. Whereas if you observe this spindle or this spindle or this spindle, here either yarn break has taken place or package has exhausted. So this package is taken out of contact with the drum. So this is the running package and this is the package out of contact with the drum. So whenever winding is to be restarted, this cradle that carries the package is taken back so that the winding resumes. Now, if you have a look at this view of the machine, then you notice that all these packages are out of contact with the drum. In introduction, I have already discussed that the operative's duty is to place the ring frame bobbins in the pockets here and clamp its end. This is the close-up view, and you see the operative placing the ring frame bobbin here, that is full ring frame bobbin here, and operative has to clamp its end here. So you can see in these spindles the ring frame bobbins are already placed and end is clamped here. So this is the reserve position of the ring frame bobbin. Running position is here. So this ring frame bobbin swings from this position to this position whenever it goes from reserve position to running position. In this machine, there was no tensioner provided, but it used to have a swinging blade type of yarn clearer, that is a mechanical yarn clearer. And other salient feature was that the setting was made with a wrench so that you have identical setting on each spindle. One has to go from spindle to spindle to change the setting of the clearer. So whenever yarn breaks, there was a mechanical sensor and it will take the winding package from running position to the position out of contact with the drum. What you see here, so these are all out of contact with the drum, whereas if you see here, this one, this is in running condition. So the knotter has just moved over the spindles, and you see this knotter, it has restarted the spindle here. So this bobbin, what you see here, so knotter is performing the knotting operation. After the knotting operation is done, this bobbin will be put to running condition. This spring, what you see here, influences the package hardness. Other very important thing what you note here is that the passage of the yarn is almost straight. In non-automatic winding machines, the passage is usually not straight. But in automatic winding machines, the passage of yarn is kept as straight as possible with minimum of deflections. In non-automatic winding machine, the passage of yarn is not straight but it has deflections. This is provided to facilitate the operator's working. In non-automatic winding machine, you can see the video. So here the passage of yarn is not straight. So the ring frame bobbin is at bottom. Then yarn passes around tensioner, clearer, a mechanical sensor, and then it goes onto the drum. This passage is provided so that the operative has minimum stress in removing the exhausted ring frame bobbin, placing the new ring frame bobbin, passing the yarn through the tensioner, clearer, etc., waxing device, etc. of the machine through the mechanical sensor, and then taking it onto the drum. So you can see that in this machine, the passage is ring frame bobbin, the yarn goes like this and then it goes for winding. So it has more deflections, which is not desired. So in automatic winding machines, the passage is kept in such a way that it facilitates the operator. So looking to the ergonomics, because all operations are done manually. So this particular passage facilitates the operative's working. But in BC spooler, the passage of yarn is almost straight. This is possible because operative has not to pass the yarn through tensioner clearer. So threading operative has not to done. It is done by the knotter. So it is common feature of all automatic winding machines that passage of yarn is kept as straight as possible. You also note that whenever a package is full on this winding machine, the operative has to replace it manually. Now to rejoin the ends, there has to be some length of yarn present on the package, that is this winding package, that is this spool. So therefore, whenever a winding package becomes full, the operative does not put an empty spool, but operative has to put spool which is having some length of yarn. So you see here, these are the spools which are not empty but they contain some length of yarn. So whenever the winding package is to be replaced, it is replaced by these spools which have some length of yarn on it, so that the knotter can tie the knot between the winding package and the ring frame bobbin. Thus, The major points what I would like to say here, that how this machine differs from a non-automatic winding machine, that it has got a knotter. Now the operative has to simply place the ring frame bobbins here. The replenishment of the ring frame bobbin, whenever it becomes empty, join the end from winding package and the ring frame bobbin, threading, all is done automatically by the knotter. Passage of yarn is as straight as possible, so it is almost a straight path. This machine does not employ any tensioner, but it do have a mechanical slit type of yarn clearer. So major features here is automatic knotter, straight yarn path.